This presentation is about more kinds of ionic compounds. Last presentation we talked about binary ionic compounds where we just had a metal and a non-metal combining to form an ionic compound. In this one, we're going to take you around a couple twists and turns. One of the twists is that many of the elements in the center of the table, the transition metals, have variable charges. They have several charge states that they can exist in. So, for instance, iron quite often comes in a +2 or +3 charge. Copper can form ions with +1 and +2, and many more atoms than are shown here also have multiple charges. But this is kind of a listing of ones that are fairly common. So, how do I know what charge to use? Well, it comes down to what is it paired with. So I've got three compounds with metal ions that could form variable charges, and we need to figure out what that charge is. Generally, it's just kind of reverse engineering it by looking at the ion that it is combined with. So in the first one, I've got iron combined with chlorine, and I know that chlorine typically forms ions with a -1 charge. So in order to analyze that, so if each of those three chlorines has a -1 charge, then the iron needs to have a +3 charge. So when we write this out for a name, I would write this as iron 3 chloride. So we used Roman numerals in parentheses to describe the charge on the metal ion, to differentiate it from iron 2 chloride. I can't just call up one of my friends in another lab and tell them that for a reaction they need to use iron chloride, because there's more than one kind of iron chloride. Okay, tin and oxygen would work the same way. I know that oxygen has a -2 charge. So if oxygen has a -2 charge and there's two of them, that means that I have a -4 charge on all of the oxygens. So that would mean that the one tin ion would have to have a +4 charge. So when we write out its name, we would write tin with a Roman numeral 4 oxide. Here's one that's a little twisted. Copper and phosphorus. I know that phosphorus is in my -3 column, so when I do the math here, each of those add up to -3, so 2 phosphorus ions would be -6. So to balance that out, copper would have to have a +6. So there's +6 that's distributed over 3 ions, so each ion would have to have a +2 charge. So when I name this, I would call this copper 2 phosphide. Writing formulas is a little bit easier because we already know what the charges are from the name. So in the first one, I know that cobalt has a +3 charge, manganese in the second one has a +2 charge, and then in the third one I've got iron with a +2 charge. So let's take a look at this. So I've got cobalt with a +3 charge. I know that sulfide is in the -2 column. So when I do my little crisscross, I get cobalt sulfide. So the name would just be cobalt 3 sulfide, and the formula would be CO2S3. Don't confuse the Roman numeral with the number of cobalt ions in a formula. It is just describing the charge. Okay, and the next one here, I've got manganese with a +2, oxygen with a -2. So that means that those two just combine to form a neutral compound already. So the formula would just be MnO. Iron 2 fluoride. The iron has a +2 charge, the fluorine has a -1. In order to get that to work out, I've got to have 2 fluorides for every 1 iron. So the formula would just be FeF2. There are some polyatomic ions. So polyatomic ions are another one. The only ones that, for the most part, you'll see that most of these end in 8. There are quite a few twists and turns, but the only ones that I'll have us look at are the ones that end in 8. So if you see a non-metal bundled up with several oxygen atoms, it's going to be an 8 ion. So CO3 with a -2 charge is carbonate. If I tack a hydrogen onto that, it becomes hydrogen carbonate. Sometimes we use the old-time name bicarbonate for that. We've got nitrate, phosphate, sulfate, and chlorate. There's one little twist here. I might expect you to recognize what I would call analogs. So all of the halogens combine with oxygen in the same ratios. So chlorate is ClO3 minus, bromate is BrO3 minus, and you could guess what iodate is. There are a couple of odd ones that don't fit into the 8 category there, but they come up an awful lot. Hydroxide ion comes up an awful lot. That is OH minus. Cyanide, it doesn't come up that much in our labs. I don't even know if we have any cyanide compounds in our stockroom, but you hear about it in the news occasionally, or on a crime show where somebody's poisoned with cyanide. Fun little fact is that cyanide tastes like almonds, I've been told. So if you're ever handed something to eat or drink and it tastes like almonds and you weren't expecting it to taste like almonds, then maybe you want to be careful about the amount that you consume. Okay. Then the last one, the only positive one that we'll deal with is ammonium, and that's NH4+. So let's put some of this to work here. So I've got 4 compounds to try naming. I've got potassium, I've got sulfur bundled up with a bunch of oxygen, and I just heard that sulfur, or a nonmetal like sulfur bundled up with a bunch of oxygens. Dr. Roberts is only going to test on the 8s. So that would be potassium sulfate. Okay, working to my right here, I've got that one positive ion, ammonium, and it's bundled up with nitrogen with a bunch of oxygens here, so that nitrogen with a bunch of oxygens must be nitrate. So I've got ammonium nitrate. And then I've got chlorine bundled up with a bunch of oxygens there, so that must be chlorate, if Dr. Roberts is playing straight with me. So let's see, copper chlorate. Oh, I gotta be careful here because it's one of those variable charge ions. So that one should be copper Roman numeral 2 chlorate. Did I put it in there? Yep, I did. Okay, and then the last one here, I've got calcium bundled up with hydroxide. So that would be calcium hydroxide. Okay, so we need to figure out formulas from names, and quite often this is a little bit easier, although the polyatomic ions make it a little bit more difficult. So I've got calcium and carbonate, so I know carbon is bundled up with a bunch of oxygen. Generally I have some sort of table summarizing the 8 ions on the next exam, so you don't have to like drive yourself crazy trying to memorize all these, but perhaps you might memorize a couple of these accidentally. So this first one, calcium carbonate. I know that calcium is in the 2+ column and carbonate is a -2. So that's going to work out nicely. So the formula is just CaCO3. Lithium and phosphate. Lithium is in the +1 column. Phosphate has a -3 charge, so I'm going to have to do my little crisscross, and the formula Li3PO4. Ammonium sulfate. So I know ammonium is a +1 and sulfate is a -2, and when I crisscross these, I have to be careful because when I crisscross and bring that 2 down next to the 4, I don't want someone to be confused that I have 42 hydrogens. So we put my polyatomic ion in parentheses so I don't get the subscripts kind of tied up with one another. So it's NH4 in parentheses, and then I have a little 2 subscript outside that, and then SO4. Just as an exercise here, just to make sure that people are taking the time to take a look at these, I'm going to hide a worksheet at the end of this one. So when you're done and feel fairly confident with the material, why don't you print out this portion of a worksheet and turn it in for credit. And that's the end of this presentation.